अटेंड करा. ठीक है.
This call is now being recorded.
So I think only hardly two couple of bits the third chapters are remaining. So I will finish those bits and I will post the link for chapter number 2 test. The material I have shared yesterday only, and one more test I have planned for chapter number 3 as well. Okay, so for the test number 2 or the chapter number 2 test, I will be accepting the responses till 1 o'clock only. Today at 1 o'clock, MDS lecture is there, but sir is not available because of this CET exam today only. Okay, so I will post the link for chapter test 3 also by afternoon around 1 o'clock. Okay, so complete both the tests by today itself, or for third test I will accept the responses till tomorrow morning. Okay, is it fine with everyone? Okay then. So the bits with which we are remaining from third chapter, I will directly jump to those points. So after 1 week, around 1 week, we are again meeting. So the points which we have covered in the last lecture, like communication protocols for RPC, we have discussed in the last lecture. So those were the request protocol, request reply protocol, and request reply acknowledgement protocol. So we were at the bit client server binding, I guess. Yeah, client server binding. Mm, okay. Aishwarya is saying that she needs more time. Okay. I already told that for both the tests, I will be giving whole today. By tomorrow morning, I will be stopping the responses for those two uh, tests. So that much amount of time you have with you. Okay. To be frank, I just now checked on my drive how many responses for the class test number 1 are there. So all the 68 responses are there with me, and today morning only I have stopped the responses of the previous test. So don't worry, I will okay, for that purpose I will extend the time up to tomorrow afternoon. Will it be okay? Then fine. So solve both the tests on chapter number 2 and 3. Okay. So the next bit we are going to see, that is the client server binding. So it is necessary for a client. Okay. So as a client, what is client stub, what is server stub, those all things we have studied in our last lecture. So it is necessary for a client to know the location of a server before a remote procedure call can take place between them. So without knowing the location of the server, client will not proceed for the actual execution of the procedure or its process, whatever the case is. So the process by which a client becomes associated with a server so that the calls can take place is called as a binding. So this is just the definition of binding. In this particular process, client will be associated with the server. Fine. So the server client binding process involves proper handling of several issues. So the issues are, the first one is, how does a client specify a server to which it wants to get bound. क्लायंट कसं काय आयडेंटिफाय करणार किंवा स्पेसिफाय करणार की कुठल्या पर्टिक्युलर सर्व्हरला त्याचं बाइंडिंग व्हायला पाहिजे. दिस इज द फर्स्ट इश्यू. So out of number of servers, for which particular server the particular client has to go for, that is the first issue. Second is, how does the binding process locate the specified server? Third is, when is it proper to bind a client to a server? Proper means what? At which particular time, how a particular client can recognize now the server is available and I can proceed for request to him. Okay. Fourth issue is it possible for a client to change a binding during the execution? So suppose, for example, client is bound with server number 1. In between, he want to change the binding from server number 1 to 2. So is it possible and how? And fifth issue is, can a client be simultaneously bound to multiple server that provide the same service? So is it possible to get the same service through different number of servers? So at a time, whether I will be able to bind myself with the server number 1 and 2 and 3 or many. Okay, so these 5 issues we are going to discuss now. So these binding issues are described with some of the points now. The first is server naming. So the specification by a client of a server with which it wants to communicate is primarily a naming issue. An interface name has two passes, type and an instance. Type specifies the interface itself and instance specifies a server providing the services within that interface. So या पद्धतीने आपण एखादा प्रोग्राम डिझाइन केल्यानंतर त्याचे इन्स्टन्सेस आपण प्रोग्राम मध्ये यूज करणार आहोत, बिकॉज ऑफ विच our program or algorithm will say that you are going to bound with this particular server. Okay, so the type part of an interface usually also has a version number field to distinguish between old and new versions of the interface that may have different sets of procedures or the same set of procedures with different parameters. The interface name semantics are based on an arrangement between the exporter and the importer. Therefore, interface names are created by the users. They are not dictated by the RPC package. The RPC package only dictates the means by which an importer uses an interface name to locate an exporter. So this way I will be maintaining the information of all the servers present in my network, and according to the procedure, the client will be diverted to a specific server. Then after we have to go for a specific server locating. Fine. The interface name of a server is its unique identifier. We are giving them unique name. Why? So they can be distinguished uniquely. One name will be associated with one particular server only. Thus, when a client specifies the interface name of the server for making a remote procedure call, the server must be located before the client's request message can be sent to it. Fine. So the two most commonly used methods used for this are, the first is broadcasting and second is the binding agent. So we are known with the process of broadcasting. So in this particular method, a message to locate the desired server is broadcast to all the nodes from the client node. The node on which the desired server is located, it will return the response message. Okay, so this method is easy to implement and is suitable for use in the small networks. Okay, so what it does is the client will send the message to all the server present in the network that I want this procedure. So as a response, the particular server which is having that particular procedure with him, he will reply that particular client, maybe by giving the response message, which will be uh, also recognized as an acknowledgement that my procedure is there with this particular server. Okay, so however, this particular method is expensive too. Why is that so? So suppose for example you are going for large networks. So because of the increase in the message traffic due to this involvement of all the nodes in broadcast processing, it will definitely increase the traffic in your network. So therefore, the second method, which is based on the idea of using name server, is generally used for the large network. So first technique we have seen, that is broadcasting, and second is the binding agent. Okay. So the binding agent procedure is taking place in these four bits, we can say. So the binding agent is basically a name server. A name server used to bind the client to the server by providing the client with the location information of the desired server. So in this method, a binding agent maintains a binding table, which is the mapping of a server's interface name to its locations. All the servers register themselves with the binding agent as the part of their initialization process. Then, to locate a server, client contacts the binding agent. If the server is registered with the binding agent, it returns, means the binding agent will return the handle, that is the location information of the server to the client, and then the communication between that client and the server process will start. So it is shown with the diagram over here. So your first part, that is the server registration or register itself with the binding agent, that will come at the first side. So this server will register himself with this particular binding agent. Server will give the information to this agent that I am here, and you can um, make the entry in your table about myself and whatever the data that I have. Okay, data means its location or all the things. So the registration process is done. So second, suppose the client requests the binding agent for the server's location. So client is going to perform some activity. He want the location of the server who is holding the answer for that client's request. So first of all, the client will send that particular message to the binding agent. Now the binding agent returns the server location information to the client. So now binding agent will be having the information of all those servers who have registered with him. So according to that information, the binding agent will return the information of the respective server, and then at the last, after getting the information of the related server, the client will call directly to that server. So this is the procedure, or the second part, that is the binding agent. First process was the broadcast. Whatever the request is there with the client, he will be broadcasting to all the other nodes present in the network, and whoever will be having that information, he will be sending the reply or the response message. That was the first technique. Then next is the binding time. So a client may be bound to a server at link time or a call time. Okay. So the first is binding which is done at the compile time. So in this method, the client and the server modules are programmed as if they were intended to be linked together. So for example, the server's network address can be compiled into client code by the programmer, and then it can be found by looking up the server's name in the file. So this method is used in an application whose configuration is expected to remain static for a fairly long time. जर सपोज मला एखाद्या प्रोग्राम मध्ये असं करायचं असेल की आय वॉन्ट टू बाइंड टू अ पर्टिक्युलर सर्व्हर ओनली फॉर अ फिक्स्ड अमाउंट ऑफ टाइम, so at that time I will directly give the address of the server's location. So while compiling only the binding will be done. So this is the binding at compile time. Second is binding at link time. So in this method, a server process the server process exports its service by registering itself with the binding agent as the part of initialization process. Then a client makes an import request to the binding agent for the service before making a call. So this kind of linking will be done. Means just now we have seen the example of binding agent. So we can take that example here for binding at a link time. Linking जे काही करणार आहात ते that will be done at runtime only. The binding agent binds the client and the server by returning to the client the server's handle, that is the details that are necessary for making the call to the server. So this is binding at link time, which is as good as the process we have seen, that is the binding agent. Okay, and next is binding at call time. So in this method, a client is bound to a server at the time when it calls the server for the first time during its execution. A commonly used approach for binding at call time is indirect call method. It is shown in the figure over here. So in this method, when a client calls a server for the first time, it passes the server's interface name and the arguments of the RPC call to the binding agent. The binding agent looks up the location of the target server in its binding table, and on behalf of the client, it sends an RPC call message to the target server, including in it the arguments received from the client. So when the target server returns the result to the binding agent, the binding agent returns this result to the client along with the target server's handle, so that the client can subsequently call the target servers directly. So it is shown in the figure over here. So here the first thing that is been taking place is the client process passes the server's interface name and the arguments of the RPC call to the binding agent. So first of all this information from the client side will be given to the binding agent. Secondly, the binding agent sends the RPC call message to the server, including in it the arguments received from the client. So whatever the call is there, with the arguments, the binding agent will send it to the respective server process. Now, the server returns the result of the request processing to the binding agent. Now, the server will process that particular request and he will send back the result to the binding agent. The binding agent returns this result to the client along with the server's handle. So with the result, he will have all the information of the server who has given this data to him, that is to the binding agent, as a response from binding agent to the client. And then finally, fifth procedure is the subsequent calls are sent directly from the client process to the server process, and then your communication between these two will be done. So this is called as a binding at a call time. So first of all, you have to specify your particular call is present with which particular server only. Okay, then and then only you will be getting the details of that server, and then you can process with your request to that respective server only. Fine. So these are the three techniques, or in these three way, the binding time will be calculated and the process will be followed. Then next bit is exception handling. So exception handling, whatever the exceptions are coming in all this particular procedure, how we are going to handle them, that we are going to see now. So when a remote procedure cannot be executed successfully, the server reports an error in a reply message. And RPC also fails when the client cannot contact to the server of this particular RPC procedure. So an RPC system must have an effective exception handling mechanism for reporting such failures to the client. One approach to do this is to define an exception condition for each possible error type and have the corresponding exceptions raised when an error of that type occurs, causing the exception handling procedure to be called and automatically executed in the client's environment. So with, I think you are not yet familiar with the testing part of your software, but you have gone through the software engineering process, and in that I think one chapter was there for software testing. So what you are going to see here, so whatever the number of scenarios that from a client side that will be faced, for each and every of that problem you should have a particular solution. सोल्युशन म्हणजे त्याचं काहीतरी पर्टिक्युलर उत्तर यायलाच पाहिजे असं नाही. काहीतरी जर एक्सेप्शन्स रन टाइम तुमच्या रेज होत असतील तर त्या प्रत्येक टाईपच्या एक्सेप्शनला तुमच्याकडे आन्सर असणं अपेक्षित आहे. मेनी टाइम्स you are dealing with some kind of scripts from the front end. Okay, and those script errors will be coming when you are sending some illegal type of data. So all those kind of errors should be handled in the say in the way that it should be giving you proper solution, like it will be giving a proper error message, or it will be diverting for the running procedure to another procedure. That way something should happen, but it should not give you the error message. Okay, then the RPC system designed for use with such languages generally use the method provided in conventional operating system for exception handling. One such method is to return a well-known value to the process, making a system call to indicate failure and to report the type of error by storing a suitable value in a variable in the environment of the calling program. Okay, so whatever I discussed right now, that is there in this third bit. All the solution, all the procedure should be there in your program. So for example, in Unix, the value -1 is used to indicate the failure, and the type of error is reported in the global variable error number. In an RPC, a return value indicating an error is used both for errors due to failure to communicate with the server and errors reported in the reply message from the server. I think this is not a good example. Fine, this is given for the Unix itself, not necessary. But The ultimate aim is you should handle all the exceptions present in your program before launching your product. Okay. And then coming to the security part, some implementations of RPC include the facilities for client and server authentication as well as for providing encryption based security for the calls. The encryption techniques provides the protection from eavesdropping and conceal patterns of the data and detects the attempts at modification, replay, or creation of calls. So, in other implementations of RPC that do not include security facilities, the arguments and results of the RPC are readable by anyone monitoring the communications between the caller and the callee. Therefore, in this case, if security is desired, the user must implement his or her own authentication and data encryption techniques or the mechanisms. When designing an application, the user should consider the following security issues related with the communication message. The first is the communication of the server by the client required, sorry, authentication. Is the authentication of the server by the client is required? Is the authentication of the client by the server required when the result is returned? And is it all right if the arguments and the results of the RPC are accessible to users other than the caller and the callee? So these are the three issues that we have to go for, or because of these three issues we have to go for the security purpose. So security we are covering in, I think, next chapter. So for these three reasons the security is very necessary. That is, the first is authentication of the server is required for the client. Definitely it is required. Otherwise, for which particular machine you are connecting with as a server, if it is not authenticated, you will not get proper data, as well as your valuable data will get harmed. Then second is the authentication of the client by the server required when the result is returned? So suppose I am connected with a particular server and I am getting some data as a result. But whatever the result I am getting, is it coming from the authenticated server only, or in between the communication some other third party involving and he is sending the data? So whatever the result I am getting, that should also be authenticated one. And third, is it all right if the arguments and the results of the RPC are accessible to the users other than the caller and the callee? Other than caller and the callee, that means your client and the server, whether other users should be involved in the activity of this particular RPC? If yes, what are the different um, authentications you are involving in that particular procedure? So all this part will be coming under the security for the RPC. Okay. So for better communication, your system should handle all the exceptions present um, in your program properly, as well as it should provide proper security to your system. So here it ends with our third unit. So any doubt till now? Okay, so much of the part of all the chapters of our subject distributed system are theoretical one. So uh, in previous syllabus there was practical implementation, but now the practicals are uh, decreased, we can say. So that's why actual practical implementation part is very less now. All the theoretical part is there. So just understand all the concepts theoretically, and if possible, means the algorithms that we have seen, that is RR and RRA algorithms, um, that implementation part is only there for practical of this chapter. So I think for today we will stop here with these bits, and within next 5 minutes only I will share the link of the chapter test number 2. Then I will share the material, that is PPT and the notes with you, and then I will post the link for the chapter test number 3 with you. Okay. So those who are present, they can put your attendance in the chat window, and they can leave the meeting. Thank you for today.